Hello everyone, welcome to Aptitude Made Simple. Today we are going to learn topic work and time. So this is the roadmap for learning work and time. So initially we will see real-time example for work and time. Then we will look at the prerequisite that we should do before solving the work and time problems. And then we will look at the type 1 problem, type 2 problem, type 3 problem, and type 4 problem. So let's get started. So let's take a real-time example. We have one task. We have to search for Indian Premier League information on the internet, and we need to create one document for it. So we know that Indian Premier League cricket competition. So you need to search on internet for different kind of information on it, and then you have to create one document so that you can present it to anyone. Like this is the information about Indian Premier League. So now let's assume if you are a student, you are very good with the searching on internet using computer. So you might be able to do this task in 20-30 minutes. If you are a parent, you might need some more time, like you might need 40-45 minutes to do all this work. As compared to student, you might require more time to search on internet and get the information, create document out of it. And if it's grandparent, they are not that much used to technology, so definitely they might take hour or something to do certain work. So what we observed over here, the task was same, like the work which we have to do was same, but for each person that required time to do that specific work is different. Student able to do it 20-30 minutes, parent able to do 40-45 minutes, grandparent needing 1 hour. So let's look at another task. Assume that you need to write letter for applying for a particular job, but you don't need to write email or something. You need to write letter physically, and you have to post it by going to post office. So most of us, like whoever is student or parent, may not have used post very frequently. So if we give this task to student, he'll not be able to understand which postcard he has to take, which stamp he has to apply on it. So he might need to get all this information and to write the letter and where to post it and all those things. He might require 2 hours to do that work because he need to gather information before actually writing the letter and how to post it. As a parent, you might have used a few times it actual letters you would have used it. So you might be able to do it in 1 hour or something. And if we ask with the grandparent, so at that time, like just couple of generation ago, we used to have only letters only. We were not having any email, internet and all those things. So they are very much comfortable with that and they would be able to do that work in maybe in 30 minutes only. So do you see the difference? The task is same. Now this task is same for all three type of person. Student will need 2 hours, parent will need 1 hour, and grandparent might be able to do that in 30 minutes. So what we have observed by looking at these two tasks, the efficiency of doing certain work, it's different for different person. And how it is dependent? It is dependent on the expertise of that person in that particular field. So if I'm good in particular field, I'll be able to do that task in 10 minutes. But one of my friend, he's not good in that field, he might need 1 hour for it. Same thing will happen vice versa. Like if my friend is good in certain thing, he'll be able to do that activity in 5-10 minutes. But I'm not that good in that field, I might need an hour or something. So usually in day-to-day life, you come across any office work or anything, you will see, you will have a people with different efficiency. So how to decide like how much time we will require to complete this work, that you can decide once we understand the chapter work and time. Now let's look at the prerequisite for solving the work and time problem. So first prerequisite is you should be capable of solving LCM, that is lowest common multiple, and you should be able to do it orally, preferably, because it is going to save you a lot of time. If you have not seen earlier video of HCF LCM, the link is there in the description. You can check that link before going through the work and time. This is one prerequisite, and another prerequisite is like work is nothing but eating mango. So what it happen when we say work, we don't get any clear idea. Like if I say A does certain work in 10 days, so we are not able to visualize what work he is doing. So just to make the things very simple, we are going to consider work as eating mango. So when I say A completes his work in 10 days, I mean whatever mangoes we have, all those mangoes will be eaten by A in just 10 days. Okay. So we have different kind of types of problems in work and time. So let's look at the type 1. So when we say type 1, we have question like this. They will give you that A do certain work in X days, B do certain work in that same work in Y days, and they will ask you together A and B if they work, in how much time they will be able to complete the work. So let's try to solve the problem. Yeah. A does a work in 10 days, B does a work in 15 days. In how many days they together can complete the work? So our first step for solving any work and time problem is finding LCM. So LCM of 10 and 15. So if you do that orally, take the big number out of 10, 15 and start writing the table of 15. 15 ones are 15. Is it divisible by 10? No. 15 twos are 30. Is it divisible by 10? Yes. So our LCM is 30. And whatever LCM we get, that is nothing but our total work. Total work is equal to 30 mangoes. So when 30 mangoes are eaten completely, our work is completed. You just try to correlate like that. Okay. Now here we are going to create small table. This is just for understanding. When you get expertise in solving this kind of question, you can just write numbers and you can solve the problem within couple of minutes. So first we will put person. So we have A and B over here. Then we will put total mangoes, how many mangoes we have. Then we will put number of days. So it might be number of days, it might be number of hours. Sometimes they will give you A does work in 10 hours and B do in 5 hours. So at that time, you might need to consider hours over here. So for now, they have given dates. So we are considering number of dates. And then you have to calculate 1 day speed. Okay, so let's start with A. How many mangoes we have? So even though A is there or B is there, our total work is going to get same. So 30 mangoes. How many days A required to complete that work? 10 days. Let's go for B. How many mangoes for B? 30. So total work is going to be same, irrespective it's A, B or combination of both of them. And how many days he needs to complete it? 15 days. So if you see here, for A, 10 days he eat 30 mangoes. So in 1 day, how much mango he will eat? 30 divided by 10 is equal to 3. 30 divided by 10, that is 3. Because in 10 days, he is able to eat 30 mangoes. So in 1 day, he is eating 3 mangoes. Similarly, do for B. In 15 days, he is eating 30 mangoes. So in 1 day, he will eat 30 upon 15. That is 2 mangoes. So now we are okay with A can have 3 mangoes in 1 day and B can have 2 mangoes in 1 day. Now what they're asking us, how many days they together can complete the work. So let's take A plus B. So both are going to work. Even though both are going to work, the volume or number of mangoes going to be same. And they're asking how many days they will require. So what is this 1 day speed of A and what is 1 day speed of B? 3 and 2. So if they together do it, A will eat 3 mangoes, B will eat 2 mangoes. So together they will be eating 5 mangoes. So now if they are eating 5 mangoes in 1 day, for 1 day, 5 mangoes, how many days they will need for eating 30 mangoes? So you can do straightforward 30 divided by 5. That will be 6. In 6 days, they will be able to complete all 30 mangoes. A is 3, B is 2, 3 plus 2 is 5. 30 divided by 5 will become 6. Okay, let's do one more problem of this type. A does a certain work in 10 days. B does the certain work, same work in 30 hours, 10 hours, 30 hours, and C 60 hours. So how much time is required if all of them work together. So what is our first step in solving work and time problem? LCM. You have to do LCM of 10, 30, and 60. So what is the biggest number in this 10, 30, 60? 60. So if you start writing the table of 60, 61 the 60. Is it divisible by 10 and 30? Yes. So 60 is LCM of 10, 30, 60. Total work is equal to, you can say 60 mangoes. Okay. Now again, we will create the similar table, what we created in the first problem. I will write person, then we'll write total mangoes. This pattern will remain across same, whatever kind of problem you are going to do. Total mangoes. Here, number of hours. Earlier we had number of days. Here they have given number of hours. So we need to put number of hours. Total number of hours, you can say. And then here 1 hour speed, you can say. So there we calculated 1 day speed. Here we are calculating 1 hour speed. So let's take A, B, C. A, B, C, these are 3%. Total mangoes for all of them, those are 60, 60 only. So if there is certain work, for any person there, it is going to come A, B, C, D, anyone. That work is going to be constant. The time required for that specific person might change, but work is constant. So A require how many hours to eat this 60 mangoes? 10 hours. So in 10 hours, if he is eating 60 mangoes, so in 1 hour he is eating 6 mangoes. So one hour speed is 6. For B, 30 hours he eats 60 mangoes. So 1 hour he will eat 2 mangoes. For C, 60 hours, 60 mango. So straight for a 60 by 60, that is 1. He eat 1 mango in 1 hour. So now what they are looking for? A plus B plus C. Total mangoes are going to be same. How many hours will be required? They are asking us. And if we look at the speed, we need to take A. A speed is 6. B speed is 2. C speed is 1. That is 9. So in 1 hour, if they are eating 9 mangoes, for eating 60 mangoes, how much they will need? 90 by 6. In 1 hour, they are eating 9 mangoes, right? So you do it 9 6 are 54. So you can show it as a mixed fraction. 9 6 are 54. 54 plus 6 is 60. So they will require this much of hours to complete those work. So 6 by 9. 9 6 are 54 plus 60. 60 by 9 hours they will need to complete this work or eat this 60 mangoes. Okay. Let's go to type 2 problems. So type 2 problem, they will give you A plus B do certain work in X days and A alone do in Y days. So you have to find B alone will take how much time to do that. So let's assume that A and B are 2%. Together, they require 10 hours to complete that work. And A alone is needing 20 hours to complete that work. So if B works alone, how much time he will need it? So let's try to solve the problem. The man can do a work in 5 days, and with the help of his son, he can do that work in 3 days. So first step is doing LCM of 3 and 5. So 5 ones are 5. Is it divisible by 3? No. 5 2s are 10. Is it divisible by 3? No. 5 3s are 15. Yes, it is divisible by 3 and 5 both. So LCM of 3 and 5 is 15. So total work is equal to 15 mangoes. So total work is 15 mangoes. Okay. Now what they are looking for, how much time his son will take alone to complete the work. So first write down the thing, person, total mangoes, number of days or hours what they have given days, and per day speed. If it is a number of days given, you will get per day speed. If they have given hours, you will do per hour speed. So person, let's take first as man, and then next they are giving it with the help of son. So man and man plus son is what they have given us. So number of mangoes 15. Both the places it will be 15 only. Man can do work in 5 days. So in 5 days, he is eating 15 mangoes. So one day he will eat 3 mangoes. 5 3 is 15. And man plus son, they can complete in 3 days. So in 3 days, 15. So 3 5s are 15. So man plus son, they together eat 5 mangoes. So now we are going to solve for son. Their mangoes will remain constant 15. We have to find how many number of days. First of all, you need to find the speed. So you see here, man alone speed is 3. So man alone eat 3 mangoes in one day. And with the help of son, he is eating 5. So how much his son is eating? So 3 plus something should be equal to 5. So speed of the son should be 2. 5 minus 3 will become 2. So in one day, if his son is eating 2 mangoes, for 15 mangoes, how much time he will need? Can straightforward do 15 by 2. That is 7.5 days. So the method remain constant. First you find LCM, then you write which person and find out respective speed, per day speed, and then get the answer. Let's look at the type 3 problems. So you remember the COVID situations where there was no permission for 100% capacity of work and everything. So that used to happen. Few people used to work on alternate days like Monday, Wednesday, Friday, and other people will used to work Tuesday, Thursday, Saturday, like that. So this type 3 is similar to that. A do in certain days, B do in certain days. They will give you just this value, A do in 10 days and B do in 15 days. But only the difference between type 1 and type 3 is, in type 1, all the days together A and B will work. But in type 3, they will work on alternate days. So first day if A is coming, B will not come to work. And the second day B will come to work, A will not come to work. So this may happen where you have a limited machineries and all. So at a day, one person only can work. So in such cases, we need to solve this kind of problems. So A do in X days, B do in Y days. If they work on alternate days, how much time they will require to complete the work? So let's look at the problem. A completes a work in 9 days and B completes the same work in 12 days. If they work on alternate days, how much time will be required to finish the work? So first step is common, LCM of 9 and 12. So what is the bigger number? 12. 12 ones are 12, 12 twos are 12 ones are 12. Is it divisible by 9? No. 12 twos are 24. Is it divisible by 9? No. 12 threes are 36. Is it divisible by 9? Yes. So our LCM is 36. So total work you can say 36 mangoes. If you relate it with the mangoes, that solving become easy. Otherwise, you'll go like 1 by 6, 1 by 12. You will do that kind of thing. The way traditional method we are taught in the school, that becomes very challenging. Okay, so let's look at person. Then same thing, total mangoes, number of days, 1 day, speed. So A and B. So A total mangoes for both of them will be same, 36, 36. Number of days, 9. For B, it is 12. So we know 9 fours are 36. So 1 day speed of A is 4 mango and 12 threes are 36. So 1 day speed of B is 3. So let's see. On first day, what will happen? They are going to work on alternate days. So first day, A will come for the work. He will eat 4 mangoes. Now, how many mangoes are remaining? 32. 34, 36 minus 4, 32 will be remaining. Now, second day, who will come for the work? Second day, B will come for the work. He will eat 3 mangoes. So 7 mangoes he will eat. And now 29 are remaining. Now, it will continue like this only till those 36 are over. But here you see 2 days, 7 mangoes are completed because 4 plus 3, 7. 2 days, 7 mangoes. So can we do how many days directly 36 mangoes? We cannot do like this because every day based on the which person is coming, the efficiency will change. So what you can do, you have to find the nearest multiple of 7, which is less than 36. So what is nearest multiple of 7, which is less than 36? It's 35. So you see 2 days, 7 mangoes. So how many days? 35 mangoes. You can do cross multiplication. 2 into 35 divided by 7. So can we say that 7 5 is 35, then 5 to the 10. In 10 days, 35 mangoes are finished. Okay. In 10 days, 35 mangoes are finished. How many mangoes we had initially? We had 36 mangoes. So how many mango remaining now? 1. Okay. So before solving this, just imagine in your regular school, you have 4 sessions, you go to the school for 4 hours. If you have only 1 session on that day, will you be waiting for 4 hours, or you will be just doing that 1 session and you will come back? So definitely you will attend that 1 hour session and you will come back. So now let's look at this. On the first day, A is coming. Second day, B is coming. Again, the third day, A will come. Fourth day, B will be coming. So we see here on odd days, A is coming, and on the even days, B is coming. So once 10 days are done, 11th day is the odd day. So A is going to come to work. How many mangoes are remaining? 1 mango is remaining. And what is A's speed? A's speed is 4 mango. So in 1 day, he can eat 4 mangoes, but only 1 mango is remaining. So he don't need to wait for complete day. He can just finish that 1 mango in 1 by 4. So our total time to require to complete the work is 10, 1 by 4. So this time you need to calculate whether A is coming to work or B is coming to work, because their efficiency is different. And based on that, their required time on that day to eat that 1 mango will change. If there was a B coming on that day, our time would have been 1 by 3, because he eats 3 mango in 1 day. Let's look at the next type of problem. This you would have observed it multiple times in your home. Like if you assume that you give a contract to someone for painting your house. So initially 3-4 people start working for that work. And after that, one of the person, due to some family reason or due to some any other reason, he don't come to the work. So what it happens, initially 4 people work, and then if that person doesn't continue the work, the rest of the 3 members needs to, whatever the other members apart from that person, they need to complete the work. So they will do this kind of thing, like A do in these days, and A and B started working together, and A left the job after some days. So in how much time B alone will be able to complete that work? Usually you would have observed this in your school project or many places. We start in a group of 4, and then certain one person is not able to continue with us, and only 3 of us continue the work. So definitely we will need more time if we have less people working in that thing. So this is the problem. A completes work in 15 days and B completes same work in 10 days. They started working together, and after 2 days, B left the job and A continued alone. So let's first find out the LCM of 10 and 15. So bigger number is 15, 15 ones are 15, 15 twos are 30. So LCM is 30. So total work is 30 mangoes. Okay. So let's write down the similar table again. Person, total mangoes, number of hours, so number of days, and per day speed. So let's look at for A and B. Now total mangoes for A will be also 30. For B also it will be 30. So A completes that work in 15 days. So 15 days he eat 30 mangoes. So 1 day speed is 2 mangoes. And for B, it's a 10 mangoes. 10 days he complete the 30 mangoes. So per day speed he eat 3 mango. So they started working together. So can we do A plus B speed? A plus B speed will be 2 plus 3, because A will eat 2 mangoes and B will eat 3 mangoes. So together in 1 day, they will eat 5 mangoes. Okay. Now they work together for 2 days. So if they work for 2 days together, 2 into 5. So they would have completed 10 mangoes out of 30. So now how many mangoes are remaining with us? 10 minus 10, that is 20. And who left the job? B left the job. So now B left the job, A is going to work alone. And what is A's speed? A's speed is 2 mango per day. And how many mangoes are remaining now? 20. So how many days A will need to complete those 20 mangoes? 20 divided by 2, because 20 mangoes are remaining and two mango per day is his speed. So in 10 days, A will be able to complete his this entire work. So for any problem, you have to first solve HCF, you have to first solve LCM of it, whatever numbers they have given, and then you write the total mangoes, number of days, and calculate the per day speed, and further solve your problem. Thank you.